New Syllabus Mathematics Book 2 Exercise 2E Question number 3 from this exercise. Using the elimination method, solve each of the following pairs of simultaneous equations. Fourth part from this equation, 5x plus 4y equals 11, and the second linear equation is 3x plus 5y equals 4. So step 1 is to name these two equations as equation 1 and equation 2. Since the absolute values of the coefficients of x in both the equations are not the same, so let's multiply equation 1 by 3 and equation 2 by 5 so that the absolute values of the coefficients of x in both the equations are the same. So if we multiply equation 1 by 3, we get 5 times 3, 15x, and 4 times 3, 12y, equals 11 times 3, 33. We will multiply both sides of this equation by 3, and now let's multiply equation 2 by 5, which means that we are going to multiply left hand side and right hand side of equation 2 by 5. So this equation becomes 3 times 5, 15x plus 5 times 5, 25y, and 4 times 5, 20. Since we have multiplied this equation 2, both sides of this equation 2 by 5, so we get 15x plus 25y equals 20. Now here, the absolute values of the coefficients of x in both the equation are the same. So we have 15, which is the coefficient of x in equation number 3, and 15, which is the coefficient of x in equation number 4. Now, if we subtract equation 3 from equation 4, we can eliminate variable x from these two equations. So, first I will write left hand side of equation 3, which is 15x plus 12y, and we are subtracting left hand side of equation 4 from this equation 3, so minus 15x plus 25y. And then right side of equation 3 is 33, negative right side of equation 4 is 20. Now simplification, 15x plus 12y as it is, since we have negative sign, so let's multiply this negative sign by the first term, positive 15x, then negative multiplied by positive 15x, we get negative 15x, and then minus multiplied by plus, minus 25y as it is, equals right hand side we are going to subtract 20 from 33, so their difference is positive 13. Now on the left side, positive 15x and negative 15x is 0, so positive 12y, negative 25y, their difference is negative 13y equals 13, which is the right side of the equation. And now to find y, let's divide both sides of this equation by negative 13. So on the left side, we will cancel out negative 13 by negative 13. And on the right side, we'll be having 13 upon a negative 13. So if you divide 13 by negative 13, we get negative 1, which is the value of y. Now to find x, let's substitute y equals negative 1 in equation 1. So first I will write equation 1, which is 5x plus 4y equals 11. And now I will substitute y equals negative 1 in this equation 1. So this equation 1 becomes 5x plus 4, y is equal to negative 1. So this equation becomes 4 multiplied by negative 1 equals 11. Now 4 multiplied by minus 1, it's minus 4, and 5x minus 4 equals 11 is the next step. And now to find the value of x, first of all, I will take this negative 4 from left to the right side, or you can also add positive 4, which is the additive inverse of negative 4, on both sides of this equation, so that we can eliminate a negative 4 from left side of this equation. So 5x equals 11 plus 4, 15, and to eliminate 5 from the left hand side, let's divide both sides of this equation by 5. So this equation becomes x equals 11 plus 4, 15 upon 5. Or you can also say that if we take this 5 from left to the right side, then this equation becomes x equals 15 upon 5. Now we know that 15 is the multiple of 5, which means 5 times 1, 5 times 3, 15. So we get x is equal to 3. So the solution of the simultaneous equations is x is equal to 3 and y is equal to -1. Next part from this question is 4x negative 3y equals -1 and 5x minus 2y equals 4. So again, the absolute values of the coefficients of x in both the equations are not the same. So let's multiply equation 1 by 5 and equation 2 by 4 so that the absolute values of the coefficients of x in both the equations are the same. So, but before this, let's name this equation 1 as our first equation and this 5x minus 2y equals 4 as our second equation. So I'm going to multiply equation 1 by 5 and equation 2 by 4 so that the absolute values of the coefficients of x in both the equations are the same. So let's multiply 4 times 5, 20x, and 3 times 5, 15y, and we'll also multiply right hand side of equation 1 by 5. So minus 1 multiplied by 5 is -5. And let's name this equation as our third equation, and then let's multiply this second equation, which is 5x minus 2y equals 4, by 4. Then 5 times 4, 20x, 2 times 4, 8y, and 4 times 4 equals 60. Now we have the absolute values of the coefficients of x in both the equations are the same. So if we subtract equation 3 and equation 4, we can easily eliminate x from these two equations. So to subtract equation 3 and equation 4, first I will write left hand side of equation 3, which is 20x minus 15y, and the negative sign left hand side of equation 4, which is 20x minus 8y, and then right side of equation 3, -5, and since we are subtracting, so negative sign, and then right side of equation 4, which is 16. Now simplification, 20x minus 15y as it is, we are going to multiply this negative sign by positive 20x, so this becomes -20x, and minus multiplied by minus plus 8y equals -5 minus 16 is -21. And now on the left side we have positive 20x and -20x, so their difference is 0, and -15y plus 8y, their difference is -7y equals right side -21. To find y, let's take this -7 from left to the right side, or you can also divide both sides of this equation by -7 because we want to eliminate -7 from the left hand side of this equation. So this equation becomes y equals -21 upon -7, minus multiplied by minus is plus, and 7 times 1 7, 7 times 3 21. So y is equal to 3. Okay, now to find x, let's substitute y equals 3 in equation 1. So first I will write equation 1, which is 4x minus 3y equals -1, and now I will substitute y equals 3 in this equation. So this equation becomes 4x -3 multiplied by y, since y is 3, so 3 multiplied by 3 equals -1. Now 4x as it is, 3 times 3 9, -9 equals -1. So let's take this -9 from left to the right side, so this equation becomes 4x equals -1 plus 9, and the difference is positive 8 because 9 is more than 1. And now to find x, let's take this 4 from left to the right side, or you can also divide both sides of this equation by 4 to eliminate 4 from the left hand side. So we get x equals 8 upon 4, and then we know that 8 is the multiple of 4, so 4 1 the 4, 4 times 2, 8. So the solution of the simultaneous equations is x is equal to 2 and y is equal to 3. Last part from this question number 3. Two linear equations 5x minus 4y equals 23, 2x minus 7y equals 11. Since the absolute values of the coefficients of x in both the equations are not the same, we have 5, which is the coefficient of x in equation 1, and 2, which is the coefficient of x in equation number 2. So let's multiply equation 1 by 2 and equation 2 by 5, so that the absolute values of the coefficients of x in both the equations are the same. So if you multiply equation 1 by 2, it means that we are going to multiply 5x by 2 is equal to 10x, and we will also multiply negative 4y by 2. Their product is negative 8y, and right side 23 multiplied by 2 equals 46. And if you multiply equation 2 by 5, this equation becomes 5 times 2, 10x, 7 times 5, 35, and 11 times 5, 55. Now, 10x in equation 1 and 10x in equation 2 means that the absolute values of the coefficients of x in both the equations are the same. So let's subtract equation 3 and 4 to eliminate x from these two equations. So first I will write left hand side of equation 3, which is 10x minus 8y, and then minus left hand side of equation 4, which is 10x minus 35y, equals right hand side of equation 3, 46, minus right hand side of equation 4, which is 55. And now simplification, 10x minus 8y as it is, negative 10x minus multiplied by minus positive 35y equals, if we subtract 46 from 55, negative 55, positive 46 is equal to negative 9. Now we have some cancellation, like positive 10x and negative 10x will cancel out each other, so their difference is 0, and minus 8y plus 35y means we will subtract 8 from 35, so their difference is positive 27y equals negative 9. Now to find y, let's take this 27 from left to the right side, or you can also divide both sides of this equation by 27 to eliminate 27 from left hand side. And now finally 9 ones are 9, 9 threes are 27, both 9 and 27, they are the multiples of 3 as well as 9. So we get y is equal to negative 1 upon 3. Now to find x, I am going to substitute y is equal to minus 1 upon 3 in equation 1. So first I will write equation 1, which is 5x minus 4y equals 23. So what is x? Sorry, what is y? Y is minus 1 upon 3. So by putting the value of y in this equation becomes 5x minus 4 into minus 1 upon 3, which is the value of y equals 23. Now minus 4 multiplied by minus 1, it's plus 4 upon 3 equals 23. And then let's take this positive 4 upon 3 from left to the right side. So this equation becomes 5x equals minus 4 upon 3 plus 23. And now let's take the LCM of 3 and 1, because 23 can be written as 23 upon 1. So the LCM of 1 and 3 is 3. Now LCM divided by the first denominator, 3 divided by 3, 1 will multiply it by the first numerator. Minus 4 multiplied by 1 equals minus 4. Again LCM divided by the second denominator, we have denominator here 1. So if we divide LCM 3 by 1, we get 3, and 3 multiplied by 23, 69. Now minus 4 plus 69 means we will subtract 4 from positive 69. So the difference is 65 upon 3. And now to find x, I'm going to take this 5 from left to the right side. So this equation becomes 65 upon 3 multiplied by 5. Now 5 and 65, they are the multiples of 5, which means 5 ones are 5, and then 5 threes are 15. So 13 upon 3. And if you divide 13 by 3, we get x is equal to 4 whole 1 upon 3. So the solution set of the simultaneous equations is x is equal to 4 whole 1 upon 3 and y is equal to minus 1 upon 3.